Good evening and a very warm welcome to Front Page, where the world's biggest bets on energy, compute, and intelligence reveal what the future is really made of. From state-powered renewable revolutions and continent-scale AI superfactories to the rise of world models and India's quiet semiconductor powerhouse. The next chapter of technology isn't being predicted, it's being built. And here are the headlines for tonight. Renew Power has returned to Andhra Pradesh with a massive 82,000 crore rupees full value chain renewable push from solar ingots to green hydrogen, just as Nara located. Vizag CII Summit, signaling the state's fastest investment momentum in a decade. Microsoft has connected its Wisconsin and Atlanta Fairwater data centers 700 miles apart into a single unified AI superfactory capable of training frontier models with hundreds of trillions of parameters, signaling the beginning of continental scale AI infrastructure. Fifi Lee's World Labs has unveiled Marble, a creator-ready world model that pivots from language intelligence to spatially grounded AI. And
all that stuff which were prevalent at that time, and then Android came, right? So that's how we started. But I think over a period of time, I think once Samsung and we started looking at what outcome and output can come from India, I think the expectation slowly changed into what more can Samsung do for the business? How can they impact our business? How can they make real products? And all that stuff which were prevalent at that time, and then Android came, right? So that's how we started. But I think over a period of time, I think once Samsung and we started looking at what outcome and
Good evening. Clearly, this man is playing at a different speed. After 5 years of silence, one of India's biggest renewable energy players just came storming back into Andhra Pradesh. And, yes, you guessed it, Nara Lokesh didn't just break the news, he teased it like a Netflix premiere. Today's headline is simple. Renew Power is placing a record 82,000 crore rupees bet on Andhra Pradesh. Yup, we will wait for that to sink in. So now that it has, yesterday, Lokesh posted a cryptic line. A company that stopped new projects in 2019 is coming back like a storm. Big unveil at 9 a.m. End quote. And at 9 a.m. sharp, he delivered. Renew is going all in on the entire renewable energy value chain in Andhra Pradesh. 6 gigawatt photovoltaics ingot wafer plant, 6.3 gigawatt peak hybrid sites plus BESS 2, gigawatt hydro pumped storage 300 kilotons per annum KTPA green hydrogen plant, 4.8 gigawatt peak hybrid site, their largest single location project. The total value, you ask? 82,000 crore rupees. Clearly, this is Andhra firing a green energy missile. And his exact line? After 5 years out of Andhra Pradesh, it is my proud privilege to announce that Renew is placing an all-in investment from solar ingots to green hydrogen and molecules. End quote. Well, this is a full stack bet. Manufacturing deployment, storage, hydrogen, molecules, all inside one state. So if you're wondering, who does that? Well, a company that believes the state has changed. A company that sees speed. While the world was still digesting Renew's 82,000 crore rupees drop, Andhra signed another massive agreement. Tillman Global for 15,000 crore rupees, hyperscale data center in Vizag, 300 megawatt campus, 40 acres allocated, 200 to 300 direct jobs, 800 to 1,000 indirect jobs, operational by 2028. So simply put, this is digital sovereignty on the eastern coast. And on November 14th, 15th, at the CII Partnership Summit in Visakhapatnam, Andhra is preparing to sign, and here is the list: 410 MOUs, $120 billion in investments, thousands of acres, plus lakhs of jobs. You know what? Countries don't pull numbers like this. And Andhra is doing it in 48 hours. Yes, you heard that right. This is the Lokesh playbook. Build fast, clear fast, execute fast. No drama, no excuses. Speed over ease. Speed over bureaucracy. Speed over bragging. And what is exemplary is that this isn't a one-off. In the last 17 months, $120 billion in firm commitments, 30 projects inaugurated, 82 projects foundation stoned. And here is the list of those: Google, ArcelorMittal, Cognizant, TCS, and now Renew returning in full force. So people call it ambition. Lokesh calls it hunger. His target, $1 trillion. And his line sums it up: I'll sleep well the day we have a firm commitment of $1 trillion in investments for Andhra Pradesh. End quote. This is a minister behaving like a startup founder, not asking for applause, asking for outcomes. Other states talk about ease of doing business. Andhra talks about how fast land is allotted, how fast approvals happen, how fast shovels hit the ground, and how fast the factory turns real. Lokesh's favorite point, which is, if incentives were too much, Andhra should be losing deals, not gaining them. Clearly, very fair. We said this multiple times on front page when we said why India needs more ministers like Nara Lokesh. He doesn't mudsling, he doesn't overpromise, he doesn't waste time on noise. And when that Karnataka jibe happened, you remember, he just said one line, which is, no need for that, we'll stay dignified. End quote. That's actually the tone of a state that knows it's winning. So finally, Renew coming back after 5 years is not just a corporate return. It's a market signal. Andhra Pradesh has momentum, it has speed, and it has clarity. And under Nara Lokesh, it has purpose. 15,000 crore rupees yesterday, 82,000 crore rupees today, 410 MOUs tomorrow, and does not stop there. $120 billion in 2 days, and $1 trillion target ahead. I believe it is very correct to say that this is execution at scale. And that's why there is no stopping Nara Lokesh. Speaking about no stopping, well, he has once again dropped a teaser about a global fund betting big on AP. We want to know, any guesses? Please let us know in the comments below. Also, we are pretty sure that we are all enjoying this Netflix-style investment series. Tudum. So imagine two massive cricket stadiums, one in Bengaluru, one in Chennai, now connected so perfectly that every player on both grounds plays as one single team. Depends which pavilion are they coming out from. Anyway, that's actually what Microsoft just did. The world's most valuable software company turned two data centers separated by 700 miles into one giant AI supercomputer. Not a cloud region, not a cluster. A virtual super machine that behaves like a single system. And Microsoft didn't just announce this, it unveiled an entirely new class of AI infrastructure. Today's headline is simple: Microsoft launches the world's first AI superfactory, and it spans multiple states. So let us take a moment to actually absorb that. Now that we have, earlier this year, Microsoft announced Fairwater, a special class of data centers purpose-built for AI. Today, they went further. Fairwater, Wisconsin plus Fairwater, Atlanta is equal to one AI superfactory. And this unified system brings hundreds of thousands of Blackwell GPUs, 5+ million optical connections inside a single site, 120,000 miles of new AI fiber connecting regions, 800 Gbps, GPU to GPU bandwidth, two-story GPU racks to cut cable length, closed loop liquid cooling with near zero water waste. This, as we can clearly understand, is a redesign of physics around AI compute. And yes, training jobs that took months now take weeks. In his post announcing Fairwater, Satya Nadella said this: Fairwater is our vision for a fungible fleet infrastructure that can actually serve any workload anywhere with maximum performance and efficiency. Clearly, for Microsoft, this is about making millions of GPUs behave as one organism. Nadella also revealed over 100,000 NVIDIA GB300 GPUs coming online this quarter for inference Fairwater built for pre-training, fine-tuning, RL, synthetic data generation. So all sites connected by a continent-spanning AI WAN, which basically is every gigawatt converted into maximum useful AI tokens. So it's a new philosophy. Not every gigawatt is created equal, but Microsoft wants every gigawatt to behave like one. What makes this different from traditional cloud? Well, here it is. A normal data center runs. So in Microsoft's words, it's not one site training a model. It's actually a network of sites supporting a single job, end quote. Each site contributes to the same frontier model, the same training loop, the same compute graph, the same memory state, and this is model parallelism at a planetary scale. No hyperscaler has shown this publicly before. And you know what? Microsoft just did. Microsoft's AI Superfactory delivers rack scale NV-link between 72 Blackwell GPUs, 1.8 TB per second GPU bandwidth per rack, 14 plus TB pooled memory per GPU, two-tier Ethernet back-end SONiC powered, vendor neutral switching 140 kW per rack power density, two-story architecture for low latency cable paths. Plus a closed loop cooling system that uses less water in 6 years than, wait for this, 20 homes consume annually. This solves the biggest physics challenge in AI today, which is distance, heat, bandwidth, latency, power density. So Fairwater answers all of them at once. And here is the industry shockwave. Competitors are building too. Amazon's project Rainier, 1,200 acres, 2.2 gigawatts. Google, multi-billion-dollar TPU campuses. Meta, massive training grids. OpenAI, Anthropic, dedicated GPU cities. But you know what? Microsoft's strategy is actually different. Turn every data center into part of one global AI fleet, fully elastic, fully fungible, fully interconnected. Nadella puts it quite bluntly in his internal meetings, which is, we must 10x training capacity every 18 to 24 months, end quote. Fairwater is the infrastructure to hit that curve. Frontier AI is no longer trained in a building. It's trained across geographies because models aren't doubling, they're exploding. 100 trillion parameters, 200 trillion parameters, synthetic data regimes, reinforcement learning pipelines, multimodal active agents. A single data center can't handle the next decade, but a superfactory spanning states can definitely do that, and soon spanning continents. And here is, of course, the final take on front page. Microsoft hasn't just connected two data centers, it has connected two power grids, two regions, two GPU mega clusters, two training fabrics, two generations of AI systems into one elastic compute organism designed for trillion parameter intelligence, 700 miles apart, mind you, acting like one. This is not cloud, as we mentioned. This is infrastructure for AGI. Yes, we said that. And it marks the beginning of a new era. Planet scale AI superfactories. Not tomorrow, not in 5 years, today. Please do let us know what you think in the comments below. Today, something massive happened in AI. Fifi Lee, the godmother of AI and the mentor of legendary Andre Karpathy, who helped define modern computer vision, just launched Marble, the world's first commercial creator-ready 3D world model. A world model that actually can take text, images, videos, even rough 3D layouts and turn them into fully editable, persistent 3D universes. And guess what? It's live, public, freemium, commercial, and that too today. So what Marble actually is? Well, Fifi Lee's startup World Labs wrapped a year of stealth, $230 million in capital, and months of quiet testing to launch Marble, a generative engine that creates editable 3D worlds, downloadable assets, Gaussian splats, triangle meshes, collider meshes, VR-ready scenes, frame-perfect camera paths. From text, a single photo, multiple photos, short videos, panoramas, rough 3D block layouts. So basically, this is AI making a world that doesn't collapse, mutate, or morph every time you take a step. A world with structure, volume, physics, and persistence. This is a new category in AI history, and here's why. For 12 years, AI has mastered one trick: pattern recognition, predicting what pixel or token comes next. World models flip that paradigm. They simulate, they predict consequences, they understand space, they encode cause and effect. They expose the missing half of human intelligence. So, as Fifi Lee puts it, our dreams of truly intelligent machines will not be complete without spatial intelligence, end quote. Marble is the first serious commercial attempt to make that real. Marble's launch introduces three first-in-industry features: AI native editing, move objects, change styles, regenerate sections, expand worlds, compose multiple scenes. Clearly, this is direct manipulation of a 3D universe. The chisel mode. Think of it as HTML plus CSS for 3D worlds. You set structure, AI fills in visuals. This decoupling of geometry and style is the breakthrough game engines have been chasing for years. Persistent worlds, unlike Google's Genie or Odyssey's demos. Marble generates a fixed, explorable world you can download, edit, or import into Unreal, Unity, Blender, Omniverse, or Vision Pro. This is why VFX studios, game developers, VR creators, and robotic labs are already paying attention. So until last week, world models were a research buzzword. Today, they are a market. And here's the scoreboard. World Labs, Marble, which is commercial, creator ready. Text to 3D video to 3D to 3D editing expansion VR support. Now, let's talk about Google. Genie, research preview. Impressive, but unstable, non-downloadable. Descartes or Deci, which is demos cool, but kind of lightweight. NVIDIA, Cosmos focused on robotics and physics. DeepMind, early world model papers since, well, 2018. Foundational, but not creator-facing. And then Meta's Yan LeCun, who is launching his own world model startup. We reached out to Yan for, of course, comments on the world model arms race. He did not respond. His stance remains clear. LLMs are a dead end for human level AI, end quote. And now he's putting that belief into a company. Joshua Bengio launched Law Zero, a safety first research lab building the opposite: non-agentic, trustworthy, physically grounded AI. 3 Turing Award winners. 3 different strategies. 1 battlefield. And yes, you guessed it, that battlefield is called world models. This is AI's next frontier because intelligence isn't language. Intelligence is understanding the world. A child knows a cup will fall if pushed. A robot today does not. A child understands a room from a single glance. AI today does not. A child predicts consequences in 3D. AI today does not. Clearly, you've understood where I'm going with this. Marble doesn't solve all of this, no, but it cracks the door open, commercially, publicly, for creators everywhere. Marble is just the start. As Fifi Lee wrote, the next generation of world models will enable machines to interact with the world in entirely new ways, end quote. This is code for robots that can reason, AI that can plan, agents that understand physics, systems that comprehend and not just generate. This is the missing bridge from LLMs to AGI. So in conclusion, Fifi Lee's Marble is the first creator-ready 3D generator, the first persistent world engine, the first spatial intelligence foundation stepping into the real market. Yan LeCun is building his own. Bengio is building a safety lab. DeepMind, Google, NVIDIA, all in the race. The world model era is officially underway. And with Marble, Fifi Lee just took the lead. Today on Front Page, we're taking you inside a semiconductor story that India rarely tells. The story of how one man turned a 20-member outpost in Bengaluru into Samsung's biggest semiconductor research and development base outside Korea. In our exclusive Front Page conversation, Rajesh opened up not about the milestones, but the climb, the struggle to hire when no one knew what semiconductor design meant, the pressure of building a global center from scratch, the years when scaling felt impossible, and the responsibility of creating an ecosystem India badly needed. He calls SSIR a living, breathing institution, one that has grown alongside Bengaluru's tech dreams. What makes his journey special is that he built a generation of Indian semiconductor engineers who actually now power a trillion-dollar industry. So, here is an exclusive conversation with Rajesh Krishnan, Senior Vice President and Managing Director, Samsung Semiconductor India Research, SSIR. And of course, he's in conversation with Amit Rajanayak, Senior Editorial Producer, Live Shows. Over to you, Amit. I'm sure you had a wonderful time. Happy watching.
Question that I have, Rajesh, how do you have so many buses? Okay, that's number one. Second is what's happening inside, Samsung's Semiconductor Center that needs this scale of movement every single day?
Okay, namaskara. Thank you for having me. Right. So I'm sure you didn't mean why you have so many buses.
Yeah, not semiconductor wise, but yeah, literally in the.
So I think we have a lot of employees. Most of them are very young.
Got it.
They normally tend to stay in and around our office. So,
got it.
And I think having a bus makes it a little bit easier.
Got
so
it.
I think our motivation is don't worry about transport, food, etc. You just think about what you will do at work. So the rest of the things about what I'll do for eating, how do I get to office, you don't need to worry about it, right? So that's the motivation behind providing some of these facilities. So you don't have to, worry about them, and you can come and be your best avatar of yourself. So that's why you see, and I think you see so many buses because it's not just semiconductors.
Correct.
The mobile division buses are also there.
Okay.
they also look the same. So
got it.
We are sister companies. So that's probably why you see there are there are a lot of employees across both organizations.
Got it. And what is happening inside Samsung, Semiconductor Center there? And why do you see this so much scale? I think you came in, Bangalore got established in 2006, and you were part of Samsung in 2004, where you were part of the mobile division, and you also bought 3G handset to the US market. You were the initial guy who made that happen in the market. So I want to understand that entire scale and the talent aspect here in Bangalore. So 2006 is when you guys set up versus now. I think you have more than 3,000 plus employees here.
True.
Yeah, it's a huge thing, and that also tells why there are so many buses as well. And also that is a huge talent. You have molded this company, the R&D center here from scratch. You have built the team from literally from scratch to what it is now. From 2006 to 2025 we are in. What changed, Rajesh? Like,
So maybe quick flashback. So when I joined Samsung, I joined
Correct.
as part of the mobile division.
correct, yeah.
So at that time, we didn't have memory.
Yes.
We were part of one big Samsung team.
Correct.
And I think the primary reason, so I joined Samsung Mobile for a couple of years, did 3G in the US, and then memory wanted to open a setup in Bangalore.
Correct.
I think the reason at that time was India is known for software.
Correct.
Everybody is in India. The mobile division guys seem to be doing well, so we should also invest.
Correct.
And coincidentally, at that point, I think the storage market was also evolving from a pure hardware business to hardware plus software.
Correct.
So I thought it made sense at the time. Come to India, there is a lot of software. That's how we started.
Correct.
In fact, when I started memory, I didn't start the semiconductor per se. I started the memory division.
Correct.
Most of the initial work was on software.
Got it.
Work on Linux, open source, device drivers, Windows Mobile, Symbian, all that stuff which were prevalent at that time. And then Android came, right? So that's how we started. But I think over a period of time, I think once Samsung and we started looking at what outcome and output can come from India, I think the expectation slowly changed into what more can Samsung do for the business.
Got it.
How can they impact our business? How can they make real products? I think that's how it started. So it was a very organic growth. Step by step, you did software. Okay, you're good in software. Can you do higher quality software? Can you do software which goes into products?
Correct.
I think that's been the evolution.
Correct.
And along with that, can you do the testing? So can you do temperature testing? Can you do AC/DC electrical characteristics in India?
Correct.
So slowly the labs also started building up.
Correct.
To compensate for this expectation. And along the way, I think what I realized was India is not just a software focused country. There's a lot of hardware talent.
Correct.
While compared to software, it is small.
Correct.
But I thought we had very good hardware talent. I think globally there are more software engineers than hardware.
Got it.
Same in India, but I think the volume of talent in India was quite good. So we started some hardware or pure chip design business or projects in India.
Got it.
Again, like software, we started small, but I think right now, if you see what we are doing, pretty much any product from memory which goes to market has a big footprint from India. So it's not like I supported. It's like what we have coded, what we have developed is actually going to end customers.
Got it.
So I think that way there is a lot of pride
Got it.
in the employees, and I think that also allows us to retain a lot of the key people.
Correct.
Because they can see their actual projects
Correct.
being sold in the market, deployed in the world's best data centers, deployed in latest laptops and mobiles. I think it gives a lot of pride
Correct.
that you're working on cutting edge. I think that's been the combination:
Correct.
organic growth and work on projects which have high impact,
Correct.
and thereby build the trust and competence and move.
Got it.
I think off late I've taken charge of all of SSIR,
Correct.
which
Yeah.
includes a few other businesses.
Correct.
Foundry, for example, and SOC.
Correct.
Story is very similar there. It's not very
Okay.
different.
Okay.
The story is same. I think SOC has grown even more
Got it.
than memory, so they are probably much bigger than memory, almost double.
Correct.
But I think the focus has always been ensure that you're working on real important projects which are going to market, and that's how you show what you're doing is important.
Got it.
So, and then I think it's a natural evolution, I would believe. From there.
Got it. Got it. And I think what were some of the early bets, that you took chance, like in terms of talent, in terms of partnership, or that kind of scale you grew here in Bangalore, and more than 3,000, that's huge. So what were some of the learnings for you personally to scale at this level? And it can be advice to a lot of GCCs who are planning to now come to India with a different mindset. So you guys literally have been the OGs of, setting up.
We've been here for a
Yeah.
while.
Yeah.
Yes. I think 2 or 3 things, right? And in my view, the first is I think basic intent and expectation that we do our best and we deliver the best. don't compromise on quality.
Got it.
I think that's always been my motto. Like if you can do X, I think we should try for 2X or X plus plus, do something better.
Got it.
Don't stay at what you can reach, go beyond.
Correct.
I think in my view, that brings passion, that brings a lot of trust.
Correct.
And belief in your ability.
Correct.
I think very often you work with your overseas partners or headquarters. When they see that, it changes. It's sort of how when a startup pitches to a venture.
Correct.
If they see the passion and that, I think they would have more commitment.
Correct.
So it's the same thing. I think if you have that feeling and passion to do well, I think good things happen. So I think one is, that's like hygiene for me.
Got it.
I think you keep doing that. Second is, I think we took a lot of bets in terms of jumping into projects or taking up responsibilities where we were not sure if we were ready.
Okay.
But if you miss the boat, then I think you're gone.
Got it.
So you have to get onto the bus whether you're ready or not.
Correct.
And then finish the job there.
Correct.
Quite a few were very risky.
Correct.
And in a couple of them, we didn't succeed on the first attempt.
Got it.
But I think that belief and the confidence from our partner that you are putting your best, I think allows us to jump over the hurdle.
Got it.
So the one is take a jump, be brave, take a risk. And I think if you have enough confidence, they will help you jump over the small hurdle. So they're not waiting for you to fail.
Got it.
They're looking for you to succeed.
Correct.
I think if that's the partnership mode,
Correct.
I think everything works well.
Got it.
So maybe, that was the second thing.
Correct.
Right? You take a bet and jump in even if you're not ready.
Correct.
And third is probably, maybe venture into the unknown.
Amazing.
For example, we started doing things which we didn't know how to do.
Got it.
So we went and pitched saying, hey, I would like to do this. I want to invest in this new technology. It's coming up, new spec, new standard.
Correct.
Or I don't know hardware, or I want to do layout. I can do it better than others. Today you're giving to somebody,
Correct.
right? And we don't have a team which does this.
Correct.
But looking at your ecosystem, that's Indian ecosystem, right?
Correct.
Or your neighbors in your own company, you know there is talent for certain type of work, and then maybe go pitch on that and see how that talent can do better than what's already happening.
Got it.
I think our motto is, if it's as good as what's already there, there's no point in doing.
Got it.
So, right. So if I'm trying to do something, it should be better than what's there.
Correct.
It should be better than status quo. So I think we took a few risks and pushed hard to venture into unknowns. Some of them have failed. For example, some technology bets have failed because they didn't take off in the market.
Correct.
But there's a lot of learning. Learning doesn't go.
Correct.
But quite a few have come through.
Understood.
So many of the projects we are working on now have been outcome of those bets. And they are now, they were 10 member, 20 member projects. Now they are probably 100 member, 200 member.
Damn.
So I think some of those, I think bets have come off, or venturing into not necessarily a comfort zone.
Correct.
But I think that's paid off. I think that's what I can look back. And I think failure is part of the game. So if you hope to succeed everything you do, I think we are set for disappointment.
Makes
a little bit resilience.
Correct.
That okay, things will not go your way all the while.
Correct.
Hold tight. Yeah. That
Makes sense.
That's my motto. Yeah.
Got it. And can you tell me some numbers, in terms of like building from India to the world, from the Samsung, what are some of the technologies that are going out to the rest of the world that you can, top of your mind, kind of remember? And also if there are any numbers, like how much, is it like all of the projects, it's become like a global hub for innovation for you guys from India is literally supplying to the world? Is that the story? Like,
So if you look at semiconductors, we call ourselves component suppliers.
Correct. Yeah.
Right. So the end users like you and I don't buy
semiconductor.
We buy products which use components.
Correct. Yeah.
Right. And if you look at our potential customers, everybody is global.
Amazing. Okay.
You can name your top 100 electronics manufacturers. They probably all buy from us.
Correct.
Right. And so by definition, pretty much everything we do is for a global customer.
Got it.
There are global customers who have local arms.
Correct.
So they manufacture in India, they have a factory here.
Correct.
So they source here across the globe, Asia and other places.
Correct.
So we do support all of them.
Correct.
But I think the nature of our business is such, pretty much everything we do is for a global customer.
Amazing.
And you asked about, are you the global innovation hub?
Yeah, like the...
Yes, but we're not the only one.
Correct.
I think it would be too brutish to claim we are the only ones. The rest of the world is not doing anything.
Correct.
Right?
I'm just thinking outside the Korea thing. Like I think Bangalore has emerged. I mean, the hub has emerged.
We are the biggest center outside of Korea.
Correct.
I think in terms of contribution to end product, I can safely say we contribute the most to products which go to market.
Correct.
But are we the only ones? No,
Correct.
there are other pockets, there are other R&D centers across the globe.
Correct.
And we have 3 businesses, memory, SoC and foundry.
Correct.
Each of them have their own markets,
Correct.
where they think their talent is, where they think their customers are. So each of them has their own R&D centers.
Correct.
So, and they have a certain expectation from each. I think India is the only one which has all 3 in one place.
Nice. Okay.
We are the only ones where system LSA, foundry, memory are all under one roof.
Correct.
And we can collaborate. We are on the same floor. So I think that's a bit unique for us.
Correct.
So it gives us a little bit of a leverage or advantage.
Got it.
But yeah, that's well.
Amazing. So Rajesh, moving on to AI in semiconductor, right? So it's a big topic. Everybody's talking about it. All companies are talking about. Leaders are talking about it. How it is changing, right from design to memory to your foundry to almost how mobile devices or edge use cases are being unfolded, right? So now AI has percolated every aspect of it. I would like to have your thought on in terms of how it has changed, chip architecture, the usage of AI in that aspect, and in memory, and how was it passed? I mean, you've seen everything, seen it all in the industry, then versus now. What has changed in the game? Like, is it accelerating at a much faster pace? If it is accelerating at a much faster pace, how much is it reducing the cost burden? What is the impact of the use of AI in all of these areas of semiconductor life cycle there?
So,
and that's a large question.
So I'm trying to figure out what's the best way to answer you.
Yeah, because it has to be simplified for our viewers.
Right.
Like,
so if I look at AI in semiconductors, I can probably break it into 2 parts.
Amazing.
One is actual chip design itself.
Correct. Yeah.
And how AI is used for finally making that small black thing which goes into restaurant. Right. The other is what is the environment or the ecosystem doing with it. Whether it is on a mobile phone or on your server, ChatGPT is responding something, or on your car it's doing something fancy. So that's the application side. Right?
Yeah.
So we won't go there a lot now for the sake of our discussion. I think use cases are obvious.
Yeah.
On your phones you can take pictures, do things.
Yes.
Like a lot of stuff, right? So maybe we can focus on the chip design.
Chip design, yeah.
Right. So how have things changed in the past? Again, there are 2 things. One is because of AI, and there's a lot of new requirements on the chips that we manufacture.
Got it.
Because the volume of data that is being consumed, the speed at which is being consumed is very important to give good results quickly.
Correct.
For example, if you go to a query agent and type, and if you have to wait for 10 minutes, you wouldn't go there. You want quick response.
Yes.
Which means, in the world of AI, processing a large amount of data very quickly.
Correct.
Right. So we have a lot of requirements on storage. You mentioned memory and storage. Where we want quicker access to a lot of data. And also very quick turnaround time. Like if I read some data, how quickly is it coming back? I think there are a lot of requirements which pose a technical challenge. So, and a lot of this has come in the last 3-4 years. So we were going slowly. And then somebody pressed the turbo button, like you said, F1, right? And then it just taken off.
Correct.
And now requirements are coming thick and fast. Can you do this? Can you have more terabyte? Can I read 4 KB in one shot, 10 KB in one shot, 16? So there are a lot of requirements. Like, can I read it in half the time?
Correct.
Right? So there are a lot of requirements, and and the industry needs it. Right? So it's a technical challenge for the teams working on it. So from an architecture perspective, a lot of what we see is people beginning to think on how can I support large density, quick latency, more throughput. Right? Throughput is like how many cars can go on the road. And latency, like how quickly are they going, so you can reach them quickly. Right? So we have to look at both, and total volume of cars capacity. So we are looking at architectures which are cost effective. Power efficient, which can help us to create solutions which can be deployed in AI. Right? Especially some of the edge items, they are battery powered. They're very sensitive to power. So what you plug onto a 220 volt, expectation is different from what runs off a battery. So there are those things we need to consider. So from an industry expectation, there are all these things which are happening. Right? And then once you do the architecture design, it's a question of implementing it. So that's same as before. The other part of AI that's impacted us is how AI is impacting how we do our work. That is where a lot of fear of, will AI replace us? How will it help me? Right? A lot of unset questions are there. Our view, or my personal view, is it's going to be a strong tool for you to do better than before, faster than before, develop higher quality products. For example, If I had a product which was taking 10 months to do,
Correct.
maybe with the help of AI, I can do it in 8.
Wow.
Maybe 9, maybe 7. So it probably reduces the amount of time it takes to get out. The quality of the products I expect is better. We can see proofs already.
Got it.
So that it can catch bugs which you earlier couldn't catch.
Correct.
Which means the end product is of a higher quality,
Damn.
higher reliability, and so on. And I think that's primarily where we see
Got
the
it.
end impact. And it's not done yet.
Okay.
So the possibilities are there.
Got it.
So each company has to work with some AI framework.
Correct.
And then see how to leverage it to your workflow.
Correct.
Every company has their own style
Correct.
of doing, like different people. All have cars, but every car is different, right? So
Correct.
there are nuances. So I think we need to take our LLMs and all these AI frameworks,
Correct.
tailor it to support our workflow.
Correct.
And we are doing that as we speak on each of this design
Very
part,
interesting.
testing part, layout part.
Correct.
Post silicon, once the chip comes back, how do you test?
Correct.
And I think once we figure things out,
Correct.
I think it'll become part of your everyday life. So it is sort of like how when we taught everybody C programming, then
Correct.
knowing C was not the differentiator.
Correct.
It became a basic.
Correct.
Right? Knowing C, you could code faster, finish faster.
Correct.
But the work didn't stop. You just had to do more work now.
Amazing.
So my assumption is as we go forward,
Correct.
we will start making more products.
Correct.
We can't do that today. We don't have the ability.
Correct.
We can't scale.
Correct.
So maybe with this help, we can do more products which are better and faster.
And just a quick question on the, I know it's a little futuristic, on the networking side. So I think Samsung has been instrumental in building the RAN systems that, I don't know what you call now.
Radio access network.
Radio access network. So now it's changing towards 6G and all of that. So there, I'm hearing a lot of things on how AI is being integrated in the network layer kind of a thing as well. So what a fascinating thing that as a leader who has worked on a 3G system versus on 6G, what is changing there on the networking front? I know they're calling it AI RAN now. It's like
True.
Yeah,
So
it's a very
I think you can add AI to everything, right? So,
yeah.
So this comes under our mobile division.
Correct, yeah.
Right. So there also, if you see, we have two components to networking.
Correct.
One is actual stuff which sits on your mobile.
Correct.
Right, which makes a call. There is an
Correct.
RF.
Yeah.
And there is the network side, which
Correct.
is what your network providers who give
Yeah.
your subscription. So there are, I think Samsung is one of the key contributors. We had a big order in
Correct.
India.
Wow.
We established. I think the key in 6G and 5G is it allows a lot of new features.
Correct.
5G is, in my view, primarily it's like a huge bandwidth, much more download, faster capability. But 6G comes with new features.
Correct.
For example, vehicle-to-vehicle protocols.
Got it.
Short-range protocols. So what it means is that through that protocol, you can talk to a base station, which is like smart cities was a good example earlier.
Yes.
You would have small microscopic base stations across. So the electric pole would know a car is passing.
Wow.
And it can tell you there's an accident up ahead, go left. So I think I think we can imagine what we want.
Correct.
In terms of what are the end use cases. I think it's unlimited.
Yeah.
But I think the key idea is it's opening up a new level of communication,
Correct.
which is very short range,
Correct.
very real time.
Correct.
Which also means you need a lot of edge computing, a lot of processing on the edge.
Correct.
So in your car, you need something which can decide on the fly.
Correct.
You can't wait to send it to the web, wait for the answer, right?
Absolutely, yeah.
So there is some architectural what can be done here versus what can be done there.
Got it.
I think there's a lot of work happening there.
Got it.
And the networking also supports some of those features.
Correct.
So which vehicle, which identity is moving where.
Correct.
So they provide a lot of these features as well.
So my one, I think this
that's
is
my
take,
very long distance
view.
Since
Okay.
I don't work
So
deeply
just
on
I
it.
know this is a very redundant question. So already we have 3G, 4G, 2G infrastructure already in place. I'm kind of like thinking out loud. Can it be upgraded to 5G, 6G with in any possible way with the architecture of the existing one? Can it be upgraded?
I'm not sure.
Sure, how? Okay.
I'm not sure. My guess is it should be possible.
Okay.
Like every equipment,
Correct.
you buy a car, make it petrol, they will do something, make it. So I'm sure there is a way
Convertible to-
Yeah, I don't think they'll have to throw something to.
Create a new one.
Yeah, I don't
Understood.
think. I think economically it doesn't make sense.
Correct.
So my guess is it should be upgradable, though at a cost, but it should be.
Correct.
Again, unqualified economic view, not a technical view. Right? So
No,
if
just
I'm a provider, I wouldn't like that, right? So
Correct.
Throw all your stuff, I'll give you new one. So
Makes sense, yeah.
purely from an economic.
Very interesting, very interesting. So now coming to I think we touched upon all the semiconductor life cycle, even we didn't leave networking also. So just quick question on, India's 3 nanometer future, right? So everybody's talking about this, and I think India has the 3 nanometer design center in Bangalore. Right, so I'm just thinking out loud. So, what does this mean for India's role in next generation chip design? Like,
I think I'm going to sound repetitive.
Oh yeah,
there are 2 parts to this.
Correct.
Right. So one is the design part.
Yeah.
Right, which is what most of the companies in Bangalore do.
Correct.
Which is
I think 20% of design talent is in India, if I'm not wrong. Like,
I'm guessing.
Yes, yeah.
Growing continuously.
Yes.
So the one part is you make the design. Sort of we can look at it like an architect for your house who designs everything.
Correct.
And makes the blueprint.
Correct.
And then the rest is actually how you manufacture or fabricate.
Correct.
That's a fab.
Correct.
We don't have them in the same numbers in India.
Understood.
Right? So that's actual. So in the fab, take a design.
Correct.
And actually realize a chip.
Correct.
Which is running at 3 nanometer. You can pick whatever numbers you want.
Correct.
I think SCL is at 180. There is some new fabs which are coming at 28.
Correct.
Each of them are useful in their own way.
Correct.
It's not that it's old, it's not useful.
Correct.
Power electronics require older nodes because they can't handle miniaturization.
Correct.
Having said that, a lot of the expertise we build is in some sense independent of the fabrication methodology.
Understood.
So the inherent design doesn't change.
Correct.
Of the chip. What changes is finally when we finish the design, we implement it. We call design implementation. So there, the constraints on you in terms of how you place the things, how you draw the wires between 2 people,
Correct.
what should be the clock frequency, etc. So there, a 28 nanometer will have a certain different expectations compared to a 2 nanometer. 2 nanometer may have more leakage, but low power, somebody may be more tolerant. So the fabs who do these 2 nanometer, 4, 6, 1, etc., they usually give us parameters.
Got it.
Hey, these are the constraints. So make sure when you do your implementation,
Correct.
you stay within these constraints.
Got it.
So that's usually where the 2, 3, 4 come into picture.
Okay.
And very rarely do we have to go back and redo the design.
Correct. Yeah.
It is possible.
Got it.
But not very common.
Got it.
It is possible, but not common. So we do the design.
Correct.
And when we do the implementation, depending on, I want to do 4
Correct.
or 2.
Correct.
I talk to the corresponding fab vendor, get their PDK,
Correct.
which is the development kit they make,
Got
which
it.
tells me all the parameters, how I should stitch up the whole thing.
Correct.
And then do it and give it to them and it comes back. So to that extent, I think everybody in India should be able to work on 2 or 4. It's an extension of
Got it.
the same. It's the same game,
Same.
slightly different parameters.
Got it.
Some are easy, some are tough, but
Got it. And now coming to the final, right? So India, like it has become a semiconductor hub now. Everybody's talking about it. Government
the real Silicon Valley.
Yeah, real Silicon Valley. Yeah, and I think government is also supporting in a large way. I just want to understand, like, the next decade. If next decade is India, I know it's already here. But what is like? What do you think we should get it right today to actually lead the way for becoming semiconductor hub in India and make it what should we do it right now? Like, what do you think?
My view,
Yeah.
one is I think we should have the full semiconductor ecosystem.
Understood.
I think today we mostly have the design ecosystem.
Correct. Yeah.
Right, and which is very strong, very well regarded.
Correct.
I think US is also very similar.
Got it.
In the past, it had the whole ecosystem. It had the fab, everything.
Got it.
But I think it's also losing out in the race.
Okay.
So they're also now trying to invest, just like our government, which is also trying to invest
Correct.
to create the whole ecosystem where it is not just design,
Correct.
but we focus on the full life cycle.
Yes.
Where you do the design, you do the manufacturing. And then you do the ATMP, you do the
Correct.
packaging, post-silicon. Right?
Correct.
So we are trying to see if the whole ecosystem or life cycle is there.
Correct.
So in my view, having the whole ecosystem
Correct.
is key.
Correct.
I think in the keynote today, I was sharing, ISA had shared that
Correct.
the government initiatives are now seeing fruit.
Correct. Yeah.
There are a lot of people who have already invested. I
Correct.
think almost 15 plus companies on the back end.
Correct.
So we still don't have the fab.
Correct.
in numbers, but once the chip comes, once the wafer comes, cutting the chips out, putting them together, bonding them, putting the lines out, testing them, all that is, we have investments there. So I think it's a step-by-step process. There are some fabs already. I saw a 28 nanometer in the ISA slide.
Got it.
So maybe it's not 2, but it's 28.
28, okay.
And it is still a very viable, it's a commercially viable solution. It's not an R&D facility. We can make money out of it. So I guess it's a good thing to start. You need the whole ecosystem. Otherwise, you make some and then you go somewhere else. And
makes sense.
That's my view. So that's one.
And
maybe the other part is once you start having companies, Indian companies manufacture in India, which is what I think a lot of the US companies have an advantage or China has. I think local companies will fuel this even more. We have a lot of demand, but not a lot of production per se. So the demand is high. India as a country has a high demand. But I believe that if the production, if companies come which are manufacturing here, producing this, consuming the outcome of the semiconductor chain, I think that would fuel it even more. That's what I think.
Very nice. Thank you for that, Rajesh. It was a very wonderful conversation. Just final thought. I mean, you're managing a huge team of 3,000 people here. So what's next for Samsung? Semiconductor India. Research in terms of. What's next for you guys? What are you planning in terms of expanding? Are you guys hiring and any kind of college collaborations and what does it take for someone to work at Samsung Semiconductor Center?
Okay. I'll start. So are we hiring? We're always hiring. Right? So good people are always welcome. I think every company will tell you the same. We are always hiring. What is our goal? I think we are pretty good at execution. We have center of excellence in certain domains. And now we have moved towards full product management. I think we are doing quite well. What the next bar for us is maybe thought leadership.
Understood.
For example, are our employees well regarded globally?
Amazing.
Are they setting the benchmark in global standards?
Correct.
I think that's our next benchmark. I think doing is possible. Managing full products, not a problem.
Got it.
And I think now the time has come for us to actively influence how new architectures emerge, how new standards evolve.
Wow.
Right. So I think that's where we think we should go next.
Got it.
Not only as a company, as a country also. I think there are a lot of people in different companies who are at that level. I think we need more in numbers.
Got it.
I hope in Samsung we can provide some of those numbers as we go forward. And so that's our goal. Not necessarily grow in terms of scale, but grow in terms of impact and the value we can bring.
Amazing.
So that's at least my motto. And what does it take for somebody to come to work in Samsung? Maybe a lot of passion.
Got it.
And I think we had a tagline earlier, impossible is nothing.
Correct.
So I think I believe in it. I think we've done it time and again. I think that's about it. Have a lot of passion to the work and believe it can be done. And I think it's usually getting done.
Yeah. I think the culture also is amazing. I was just talking to a few of the people from Samsung. Most of I think are staying here for more than 10 years, 5 years. I mean, it's like they've been part of the journey for a very long time. What is that one culture at Samsung that makes them stay for long?
I think I would like to think of it as a big startup, which means it's a lot of exciting, lot of new technology to work.
Correct.
I think that's what engineers like.
Correct.
Not some, I tell you what to do and you do and then you keep doing it forever.
Correct.
So I feel that's our USP.
Correct.
It's sort of like a startup under the umbrella of a very stable company.
Correct.
But the environment is very startupish. A lot of new tech, a lot of opportunity to look left, right. There are no real boundaries and that don't do this, don't do this. I think there's a level playing field for you to try a lot of things. I believe that's our USP.
Amazing. That's it, folks. That was Rajesh Krishnan, Senior Vice President and Managing Director at Samsung Semiconductor India Research. Thank you for your time. That was a wonderful conversation and wishing you all the best. And may I see more buses in Bangalore and someday even metros, if possible. Yeah. Lovely meeting you. Thank you.
Thank you very much.
Thank you so much.